Let's read for 5 minutes. Let's read for good. People are joining. Is there 2-3 minutes? Let's start. Hello, Tapas. Hello, Tapas. Are you able to hear?
Hello. Are you guys
Hello,
able to
Tapas.
hear me? Yes, are you
Now
guys
we
able
are,
to hear me?
yes, we are able to hear now.
Okay, great. Very good morning, everyone. So, Rishiba, are we waiting for few more people?
I can
Join?
start. Tapas and Samya. If anyone wants to join, they join. You can start. Yes, I will give you the permission and you can start.
Sure, sure. Okay, so guys, I just want to have a quick introduction of myself. So this is Tapas. So I am here today to give you a brief introduction of the system design course and what we are going to do in future and how we are going to shape up. But in that respect, I don't want to waste your time of 45 minutes or 1 hour. Rather than I am just trying to tell you what exactly a system design and what exactly uh, it looks like and how we do work, all those things. And in coming classes, we will probably go through the bigger picture of system design and all the components, how we start, and all those things. But before that, I just want to give a heads up of system design. You guys should understand why we come to this course or what exactly system design, take it further. So are you able to see my screen first of all, guys? Anyone is there? Can somebody confirm that you are able to see my screen?
Yes.
Superb. Superb. And guys, I just want this session to be very interactive rather than I will be talking and you will be, uh, kind of listening the story and you are not liking, you are not telling me, and you are liking, you are not telling me. So, and you may have different ideas and different thoughts. Even you can share that, right? So, guys, before getting into the call, uh, getting into the topic, can I quickly understand who is having how many years of experience? Can somebody start, or you can put in the chat also, so that it will be easy for me. So I could see that okay, Rishiba is there, who is the coordinator, who is helping you guys. Naidu. So can you you know let me see where exactly, guys. Okay, okay. So Deepak is 19 years experience. Sharma ji is having around 12 years experience. Sarad is 13 years. Somebody joined from Samsung Mobile, which is 2.4 years. Naidu is 15 years experience. Okay. Rest of all, anybody? And guys, can you open your, when Deepak, can you just, let me know what is, your uh, thought, what exactly you want to take away from this class? Maybe two lines. I don't want to get into more things, but Deepak, okay, D. Sharma, can you? This will help, what exactly it will help, it will help me understanding what exactly uh, you are looking for. Okay, so people, because this is a very, very, this is a topic which has been already taught to us when you are might be in engineering or in masters everywhere. Okay, but now when maybe working 19 years, we might have forget all those things. But now the things have been changed in last 19 years or 10 years or 20 years. It has been changed, drastically changed, right? So the SDLC has been dynamically evolving and changing, right? So okay, Deepak is not able to unmute himself. Let me see if I can. Rishiba, can people speak actually? You have not given or some permission needed. Deepak also not able to unmute. Rishiba, are you there? Rishiba, can you unmute Deepak, Naidu, Sarath so that it will be more or less little interactive section because I could see they are quite experienced. Okay, Rishiba, I'm not able to give me a second, guys.
Tapas, can you repeat the question?
Look, okay, can you please unmute others so that they can ask questions or they can probably interact it because I could see that they are quite experienced people.
Well,
Mostly put Deepak, yeah, everybody. I think everybody should have some access to talk actually. Okay, few of the questions I got it. Somebody is looking for practical example. Somebody trying to understand why system design is needed. Fantastic. We will go through why system design is needed. How generic system design. Sarmaji is looking for design fit into cloud environment like AWS and Azure. Great. Great. So guys, today I'm going to talk about maybe why system design and why it is needed, or probably, we will see like mostly we will try to understand like what you can achieve. So guys, if you remember what you studied during your college, during college, engineering, masters or something, whatever if you have not studied on those and you are from different background, that's also fine. So system design is needed. Okay. Let me put it in this way. So when you are trying to cook some curry, let's talk on that way, right? You are trying to uh, let's take a vegetarian curry because that will be a fantastic one. So let's say that you want to try to have paneer curry or maybe some paneer special curries, like uh, and some guests are coming and they like it. They generally like that paneer curry. And so what you are going to do first? You need to bring paneer and you need to bring all the ingredients, small ingredients, which is going to enhance the taste of that particular paneer. It's starting from salt, starting from different uh, you know uh, flavorful ingredients. It's like maybe uh, making whatever needed for your gravy. You get it, then you start cooking it, right? You don't do you start cooking, then you try to get everything right. It's not like that, right? First you first plan, right? What kind of curry I'm going to prepare, because in a paneer I can do different styles of curries. But what exactly the customer need, or the person who is coming to my house, what my friend need, that kind of curry I'm going to make it, right? So then in that way, you have to, let's say paneer is your main ingredient, right? But there are other stuffs are there, whether I want to heat it in a low heat or high heat, whether I need to fry it or whether I need to soak in the hot water. So whatever, this is the way you first plan accordingly, right? Then we start, everything is next to you, then you start the preparing curry, right? So you can't do like, putting something on the fire and you go for something else to bring, to go to the market to bring something, onion, garlic, or something, right? You don't do that. Right? This is where any system, anything you want to design in anywhere, this is the same thing. You can't go in between, stop the things and get the things which is not happening. That's how we design any kind of system, any kind of. I just given an example so that it will be interest who don't have interest in cooking, that's fine. I mean, like I can give different, examples. Let's say a car manufacturing company. So what they do, they talk to their all suppliers, get all the things uh, next to them. Then they start assembling it, right? So I mean, like somebody gives the door, somebody gives internal interior, somebody gives the headlight, somebody gives the chips what it been used, somebody gives all the parts. So that's how the system get designed, right? That's how they first plan it. Okay, this is what I need. Then they start putting together and what we call assembling. And similarly in software also we have system design, right? Basically, I imagine, okay, let's say I want a small application. What, let's say, Deepak want to talk to D Sharma. So how he is going to, okay, Deepak, okay, I could see that a lot of people left. Rishika, can you confirm how many people are there? Okay. So I'll just quickly get into the things like, basically you need different ingredients to you know design something or design a workable application where it could give, it could take some inputs and it could give some outputs, right? The desired outputs when I say. So the system could be anything, any small system or a big system, right? So if you look into the early days when we, maybe I'm talking about 10, 15 years back, so everything was okay. Can anybody tell me what do you think that what is a system design? I just want to put your thoughts over here. I want to draft it. What does it mean by system design for you? Can you write it down here so that I can copy paste that and I'll put it? That's your thought about the system design. Hello. Yes. Yes. Can you just help me understanding what's your thought about a system design? If you can write it, I'll just copy paste it here, and I will, then we will go through. Then we will understand whether that's correct or not. Hello. Okay. So if you think that you okay, I think I could see that people are joining from their mobile. I'm not sure whether they can write it like, what is their thought about system design. But let me take, uh, what exactly the earth think about a system design and what exactly needed for a system design, right? So the system design consists of plans, functions, non-functional aspects of complete end-to-end flow of an idea which maybe solves some high-value problem, right? So when he says some high-value problem, maybe let's think of a uh, railway accidental stop system, or or maybe a lift, how a lift works, or maybe the entire e-commerce system, or let's think of everyday morning you are trying to do some kind of purchasing or some kind of service from some other company and it's availing to you, right? So those end-to-end systems, right, whether functionally or non-functionally. When I say functionally, it is basically the each and every aspect of the service, right? That is called functionally. And non-functionally, I think somebody has clearly mentioned, right, what I want to learn, how security, how how kind of scalability, or let's say there are 1 million subscribers are there for that particular service, how it has been used, or how it has been basically that aspect has been uh, taken care within the system. So those are basically non-functional aspects. And functionally, let's say e-commerce, I want to purchase something and it should come and deliver to my home with the correct specification. That's my functional testing, functionals, right? So that is what I need end of the system. So what is the goal? The goal is to create well organized and efficient structure that meets the intent purpose, as I say, while considering factors like scalability, maintainability, and performance, right? So when I look for a system design, these are three major factors which basically highly needed a system to well behave, well perform, and functionally correct, right? So it should be scalable, maintainable, and the performance should be very high. And this is what the real world need, right? If you will find a symbol downloading, or uh, how many of you guys are using some kind of network which is very low bandwidth? No, nobody is using any application. Let me know in modern days which will be okay. So look into the Netflix, look into the G OTT or any other OTT platform. Why Netflix is outstanding? Why Netflix is different from others? Only because of this, right? It is scalable. I mean, like millions of users are using this Netflix at the same point of time. But if you could see, I mean, because this is what my observation. If I look into G, or if I look into some other OTTs, they are not scalable as Netflix. And when you say maintainability, the way they are maintaining, the way they are adding the contents in the background, it's even I have seen where OTT like Star and G, which has been downed also for few minutes or few seconds or few contents will be there, but those things are not, they are in the in Netflix or Amazon. Why? Because the performance is really really high, and the way they maintain the entire system is you know totally different, because the way they have designed the entire system during their maintenance, during their context switching, nothing can hamper or no downtime to their system, right? That is how you need to think of when you are designing a system. How I'm going to design my system so that even though I'm doing some maintenance, but people will able to avail the services, right? So how basically, whenever I'm looking for a system design, these are the three computer aspects or you need to take care. One is computer networking, one is the distribution system, and parallel computing. This is what, when we are talking about scalability, maintainability, and performance, this is where all these three things are coming as a compute, as basically when I say, as I say, like there are two aspects. Every system have two aspects, one hardware and one software. Software, what is you are going to design, but when you are designing your software, then you need to take care of hardware utilizations too, right? How your computing should be, how your networking should be, how your storage should be, which all things you want to store, which could be a relational database, where which should be a NoSQL database. Those things you need to take care, right? How you are designing your front end, back end, and how the data get handled for this entire stuff. That is what is all about called system design, right? The entire system, the end to end system, how you are going to design, that is what uh, we will go through during this journey, and we will understand more. But today, I will just take you through why we came to this course and what exactly the modern days of system design. Those things we are going to look into. Guys, any questions so far? Let me check. if somebody have some questions. Okay. Rishipa, can we, probably open this thing so people can talk? I could see that Deepak have the access. I'm not sure others have that access or not. Rishipa, can we give?
Hello, Tapas.
Yeah, Rishipa.
Can you tell me what were you saying?
No, I was asking, can we give people access that they can also unmute themselves and speak, so that it will
Actually,
be
I've
very
given them the permission. Tapas, I have given them the permission to unmute.
okay.
Unmute
Guys,
themselves.
yeah. So far, guys, you have any questions or you have any suggestion or you have any thought, please let us know. I mean, like, because I don't want a session to be just, I will be go through the PPTs and you will be just listening. It does not work in that way, right? It's a system design. I'll, for me, uh, I don't believe, there are arguments which you might have, which I can't, clear without you guys talking. I would love that you should talk. You should tell what exactly you are looking for and what's your experience, so that we will probably add some fuel to that or add some more ingredient to that, right, guys?
I think uh, people should please, if you want to build a scalable system like Amazon and Netflix, if you want to study the, maybe it is better if you start asking some questions, because it will also cover. I think people are not aware, but parents system design also covers the macro. A lot of people have come up like they are moved to their different teams and all that, but and we are looking for a microservice architecture. But system design in today's world, it is not like a previous system design, older system design. It does cover the microservice architecture. So if you have any doubts, please communicate. Please ask questions.
Okay, thanks, Rishiva. Guys, did you understood so far what is system design? What exactly? I think this is one of the question by somebody. What exactly the system design is? If you still have some doubts, please let me know so that I would love to clarify it. Okay. So, what are the objective of a system design? I mean, what do you think that what are the objectives of system design, guys? Any guesses, guys?
Yeah, so probably I'll take it that office. So it should be more
Deepak?
like the way I look at it is it should be more robust in such a way that it should be like highly reliable, maintainable, scalable, uh, configurable, or component wise, right? Basically, easy to modularize, basically, right? So that it's up all the time without any disruptions and in a secured way.
Right, right. You are absolutely. I mean, great answer. So basically, when I look for a system design, okay, let's think of something, right? Your kid asks, hey dad, can you create a game for me? Okay. So practicality, I started. Let's say, you all also started, and you created a game. Okay. But unfortunately, he don't have access and he is not able to use it. Only you can use it. But is it sellable? No, right? Only you can use it. I mean, the kid who actually asked for it, he can't use it. So what is the use of that kind of system when it can't be usable by person? Okay, that's the first thing. First, then second is comes like it should not be, somebody should not ask like, okay, I want a ladder to moon, right? It's not practical, right? Maybe, I can fly to moon, but I can't get a ladder to moon. Or even in that case, I can't get a ladder to Mount Everest, right? So those are certain things we need to understand when we are designing a system. Uh, Maybe future it may happen or it may, but when you are designing, you should think of, right? You should not say that, okay, hey guys, I can design it. No, sometimes there are barriers, right? You should understand during the feasibility study of that design whether it is doable or not doable, right? uh, let's say somebody asks you, I want to, while I'm driving, I want to play, uh, a game on my infotainment system, but is it, is it correct? Practically, is it correct? Because if I am driving, how I will concentrate on my driving when if I am looking into my infotainment system to have a game? It's not possible, right? So that's where the practicality comes into picture, right? Whether it's practical or not. So that's we need to be, visible. Then the accuracy. So mostly when I design a system, how accurate it is. Let's say, basically, if you guys remember the Mario game, I'm not sure how many of you have played those Mario games who are actually 2020, maybe uh, 10 years down to the line. Mario was one of the popular game among everywhere. You guys have seen, right? The Mario jumps, it goes somewhere, hits somewhere, and then it gets something. If let's say, if I put Mario and it will be hit somewhere at all, also, even though the coins has been not written, the coins will be coming. Or let's say that there is, somewhere it need to go get into a place where to hide or somewhere. If that is not happening at all, but Mario is running, and even tortoise are hitting him, those bad tortoise, and Mario is not, nothing is happening. Mario is, very powerful. Mario is keep on running, but the accuracy is not there, right? I mean, like, there is no accuracy. First of all, let's say I'm trying to get a picture. Let's say you guys are all using a mobile, right? The mobile, it is written 48 megapixel camera with high resolution and all those things, right? But when you took the photo, even 10-meter distance also, it is not able to capture that photo correctly. Then how come it become accurate, right? It's not accurate, right? The specification what it is written there, it's not up to that. It's not accurate. What exactly I am looking for, that's not accurate, right? That's where the accuracy is mostly calculated, on a percentage. So you guys might have seen Google Map also, right? So when Google Map says, okay, so it gives a radius. Let's say where I am, it gives a radius of 25-meter, 5-meter, 10-meter. So my house could be within that range. So, and most of the time it is 99 point accurate, right? So if it is giving five, within 5-meter radius or 1-meter radius, it's basically accurate, right? I can move around and I can walk around within that 5 meter or something. And that is the accuracy what that system maintains, right? Then completeness. So when you say completeness, basically, as I given an example, my son is asking for a game and it should have a end-to-end game. He should play, enjoy, and basically whatever functionality he was looking for, that should be there. When I'm designing, I should think of how I'm going to, okay, let somebody ask you to design something, let's say e-commerce, right? Uh, do you think that always in e-commerce, the payments should be always you know, on cash, or payment should be payment? Let's think of, I am purchasing something and payment is always okay. It will be written 10 rupees, but there is no way to pay it, right? So how I'm going to complete that cycle? Either it should be, any kind of payment, right? Whether it's a UPI pay, it's a card pay, or it should be cash on delivery. It should be any kind of pay. nowadays, if you see, there are a lot of companies which are removing cash on delivery because they found that's a fraud, right? People ordered, but they don't take it. Even in few, even I would say cash on delivery is not a completeness because I am purchasing something, I'm not paying anything. I'm waiting that money, that's a facility which has been given. But in future, if you will see, most of the companies are going to remove that particular thing. That was something which has been designed to attract people, but nowadays I think modern applications I am not seeing at all. In if any application, if you are using from US, where you have to pay through Amex or something, you could see there is no cash on delivery available in that area itself because that's not a completeness because and in a cycle of e-commerce payment and the fulfillment, that's called completeness, right? So you should think of the system. Let's say you are designing the best system, but half the way you think that okay, no, um, it may not be in that way. If you'll go, it may not go to that completeness, right? So you should think of that way, right? So how all my requirements is going to get fulfilled. Efficiency. Okay, efficiency is anyway, you guys know what is efficiency means, right? I want 300 Mbps means it should be 300 Mbps, right? Why the speed should not be there? So basically, when I think of efficiency, so then every page, every page or every application have some efficiency. So can you guys name what you feel which is a inefficient application at the modern era? Any example anybody can give? Any
So for
thoughts?
for
Yeah.
efficiency,
Yes. Yes. Yes.
yeah, the German engineered cars, right? They are known for being reliable and efficient.
Reliability is fine. When you say efficient, how German engineering are efficient? So what do you mean by efficient there? A very good thought. But can you explain how you can? We will come to reliable. It's a different topic altogether. But efficient. When you say efficient, so why you say that German engineering are efficient? Even there are US cars are there. Even the most. Uh, if you look into any city in India, the most efficient MUV or what you say SUV which runs, that is called Toyota. What is that? Toyota cars, right? So Innova. So don't you think that that's efficient? So what brings you saying that basically German cars are efficient?
Uh, just thinking, is it more to do with the metrics of pick up, right? When you start,
Hmm.
uh,
Awesome. Yeah, you are on the right track. You are on the right track. Okay. So basically, you look into any car. So what they say, which car is 0 to 6, if it can go faster within 0 to 100 speed with 0 to 6 seconds, 0 to 6 seconds, then it's more efficient, right? So so in that particular, I am looking for my pickup is very efficient, right? Or let's say I travel for 1,000 kilometers the same day, but the engine didn't got heat or the engine didn't give any trouble because the engines are very efficient that time, and German cars are well known for their engine efficiency. So when I say engine efficiency, it does not unless until you are not driven per day 700 800 kilometers, the engine is not going to even get heat. When I say get heated, in inner circles or expansion of those engines, those are the aspects, right? So that is where we call efficient. But let's think of a e-commerce or any kind of other systems. Let's say Amazon, AWS, Amazon. I mean, like your Amazon, when you are doing a kind of a procurement, or you are trying to get some retail stuffs in Amazon. So what you will say efficiency on that? I mean, it's a question to everyone, not to. What do you mean by efficiency on that particular website?
It could
The
be
response time. Oh,
responsiveness.
go ahead.
It could be responsiveness as well.
Absolutely, absolutely. So basically, let's say I'm searching for a particular product, right? There might be thousand in the catalog, or maybe millions in the catalog, the same product, correct? So let's say mobile. I am searching a mobile. I'm trying to purchase a new mobile in my Amazon website. If I put mobile, I mean like there are Tom, Dick, and Harry companies are there which will come with the same specification, right? But how fast it is getting without the search efficiency. So when you are designing such systems, you need to think of efficiency, right? Let's say banking applications. You want to do a banking, and you need to finish it. You have to deposit some of money, and you personally visit it, right? And let's say think of State Bank of India. The person who is actually taking the money at 10 o'clock, 10:30 or 11 o'clock, he will go for a tea. You spend your time, you are standing on the queue, the person has gone for tea. Once again, he will come back after 15 minutes, then he will start it. Then he will say, you have not written the name correctly, right? Then you need to take once again the form back, you have to write it. Then once again, you have to, okay, this number is missing, right? Maybe for each and every person, he is taking 10 minutes, right? But if it could be a system which is automatically prompt you, hey, this is wrong. You then and there itself you fix it, and then it predict, okay, these are also wrong things what you have given. Or let's say I give my mobile number, automatically it pop-ups everything about me. I do a verification, then I go ahead with the next rectification and just go ahead, which is takes hardly seconds, few seconds. And that is the way efficiency comes into picture, right? So why should I will be keep going to SBI branches rather than doing it on the website, right? Which is more efficient because it does not need any kind of intervention, and latency, the time of response is very high, and then that's how efficiency get measured, right? Okay, then we come to reliability. Yes, so somebody was talking about German engineering, right? How reliable they are. Look into their any sedan car what they sell, they are most reliable car, because the failure, you know getting into a failure situation is 0.0001% of any German car. If it has been maintained properly, it has been driven properly, then definitely the reliability of that particular system, or maybe get into some proximity, or maybe get into some failure condition, is very very less. I was giving an example of watching a movie in Netflix, watching a movie in G, right? You never know when G will get with that round symbol because it's loading. But as my experience with Netflix, I never saw, even though there is a latency issue in the network or something, even though that get adjusted. How? The way they have designed, or the way their caching mechanism works in between, in backside, that's where that entire reliability, the fault tolerance is very 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 high. The fault, you will hardly find any kind of fault. And these are the things what we will, when will the classes will progress, when we'll go to next classes. uh, Believe me or not, it's going to full day class, or maybe when we will go through each and every part, when we are going to design a system, it will take, because you will understand what kind of technology I can use it to do my reliability more, or what kind of processes. One second, guys, I know this is something I should have told in the beginning. Whenever I'm doing some kind of designing, it is not always I am choosing what kind of technology I'm choosing. Rather, the way I'm going to do the entire system, which comes what after what, right? So let's think of, one day your wife um, and taken a leave from the work, okay, and she told, hey, gentlemen, you are going to take care of entire house from starting from the morning vessels to cleaning the vessels, getting the food ready for the kid, sending the kid to school, and all those things. Okay, you started working, right? But I'm not sure how many of you can do that without any failure. But when it comes to your wife or your mother, they know the sequence. What should I do first? What should I do next? And all those things. The failure sequence and the environment, the ecosystem what they have created, that the failures are less. But if I given you for a day, the gentlemen, probably you are going to be messy around, right? So, so there, who is more reliable then? For a kid, who is more reliable, mother or father? Definitely, when a kid wake up and they go to school and come back, his mother is more reliable. I mean, it's a real life problem, but where I look into other systems, the failures or the environmental issues are kind of, the showstoppers, right? So, as I given an example, Netflix, or you think of Amazon, you are doing some kind of uh, let's say you are paying and the same time it got failed and you don't know money because you given the OTP and the money has been deducted from your account, but it didn't got succeed. And it happens, let's say every 10 users, 2 users get this kind of hit, which is 20% of failure. Do you think that people will go to Amazon? Nobody will go to Amazon. So you need to bring some kind of reliability in the system. Even though it got failed, in the next time or sometime it will collect the money or it will refund you, right? So there where the reliability comes into picture, right? I just given few examples, but we will see how I can achieve reliability using software technology and all those stuffs, right? And by designing things. So as I say, like my previous sentence, like rather than using software technologies, it is all your design. What, how you are designing the system, what all things you are putting after that, and how you are let's think of a small system called payment gateway. Why I am putting all these things on the e-commerce side? Because guys, I'm not a e-commerce guy. I will let me very honest, I'm not a e-commerce guy, but it is very easy to give an example on e-commerce and you guys will relate to it. Okay, but if I look into the systems, uh, okay, I didn't give my introduction. So I worked on various systems which is more or less into manufacturing and ERP, then something like indexing, and more now into automotive. So automotive industry or infotainment industry. So where I am right now. So I have those examples, but those examples may not entertain you, and because they are very domain driven. We will read this. What is called domain driven? I know we will go through that domain driven things. But why I am keep putting e-commerce? E-commerce is very nearer to you, and you know how it has been used actually, and that's where uh, things comes very easy to understand, and that's where I'm putting all those things. Okay, the next one is optimization. So what is actually optimization? Any thought? Anyway, the definition is there, but still I'm asking you guys, what do you mean by optimization? What is your thought process about optimization? Anyone?
So basically, it's the reuse of code, right? And that it
Okay,
uses less storage as well. Uh,
absolutely.
yeah.
So, yeah, so basically optimization, right? When I talk about optimization, there are a lot of things comes into optimization. Uh, so let's get into the same. I will give you a real life problem. Okay, let's say you have 10 people come to your house and your wife has to serve them, but unfortunately she prepared only for 4 people, right? Let's think of a day on a Sunday. So you have unwanted guests which came and you have to serve them, right? So she knows how to, what exactly I need to do to optimize my food and distribute it among everybody, right? That is, you can think of like that's a space, right? At the same time, she need to utilize that bare minimum time to prepare something or to do some magic so that everybody will be feeded without any empty stomach. And the same thing, she can utilize, the resources what she have. Right? That is where it is optimization come into picture. Okay, so let's get into a system, right? So when, let's say when I am doing a e-commerce system, or let's think about the automobile industry, right? Optimization. So fuel optimization. So my car should go maximum mileage with less fuel. I mean, 1 liter if I put it, it should go 20 plus. Not the car should uh, like 2 kilometer or 5 kilometer, right? So if you look into Mercedes and the cars which is very high end car, the diesel, if you will fill the diesel, it just run for 5 to 10 kilometers, not more than that. So when I say it runs, so but the efficiency, the efficiency comes into picture. The engine efficiency, the fuel consumptions are very high. So, but if you look into Indian market, whatever cars comes, they optimize their cost in such a level so that they can the fuel. Look into Maruti, right? 1 liter Alto will go 23, 24 kilometers. The way they have optimized their engine, they customize their engine and they kind of made their engine in such a way that it can take low fuel and run for longer time, right? That is where optimization comes into picture. So whenever you are designing such system, you need to think of, right, what all things I can optimize on my system so that it will consume more, consume less time and it will consume less space, because obviously the costliest thing in the work is space, right? And people who are staying in Bangalore, they know the pain. And people are staying in Mumbai also, they know the pain of, getting a house rented or purchasing that house for sole use, how cost it is. Why? Because there is no space left, right? In that these kind of cities, there is no space left. So the demand is very high, and you know, so now the builders are coming with smaller spaces with a optimized cost. So what they're trying to do, they optimizing the entire concept of living, right? Physical living, what I say. So similarly, so whenever you are designing such a thing, so you need to make sure with the space what you have, you should manage, right? Let's say how you are going to render your web pages, how uh, rather than using again and again the SQL queries, how you are going to use uh, the queries what you have or the storages what you have in a different way, right? That's where you need to think of when you are designing the system. Let's say your catalogs are going to be, let's say in e-commerce, your catalogs are going to be get pulled every time, correct? So you need to think of, right, how I'm going to optimize this calling so that it should not take more time when I'm putting that kind of query, right? So that's called optimization. Any doubt on optimization, people? Okay, let's move into we have interest of time. Like we have, let's say we will run the show for another 20 minutes. I will take you through rest of the other stuffs like various design, old designs and all. We will pick up. Okay, if anybody have no questions on optimization, I will move to scalability. Why I put scalable as a bigger chunk? There is a reason. I mean, like when I say scalability, it's basically a flexibility, right? Whenever I am designing a system, I should think of how my system can adopt something from external, or my system can be used by somebody, right? And the number of people, basically, let's say today 100 people are using, tomorrow 1 million people are going to use, next day 10 million people are going to use. So I don't need to basically do that, every time I should not come and, do some code changes, do some hardware, software changes by physically, then only my system will get scaled. So we think of some kind of auto scaling mechanism where my system will be automatically get scaled, whether it is, getting scaled horizontally or whether it is getting scaled vertically. I don't care, but it has to scale. Then we will understand, like when we will design the system, we will go through why not horizontal, why vertical, why horizontal. We will understand, because those are once again the optimization cost will come into picture, right? If I want to make a scalable system, how optimized my system is, then that scalable it is. So let's say today you why right now clouds are very famous. Anybody can give me answer. Sorry. Can anybody tell why cloud is so famous nowadays? No answer?
So basically, it can be used anywhere, right? Like you're not stuck to a particular location or a particular hardware that we use. Uh, yeah, it's easy to maintain and be scalable and accessible across any locations.
Right. So basically, I would say, maintainability and scalability is very, very high. Guys, who is having a hard drive at home? Tell me. I mean, I believe you guys, being 15, 16 years experience, you should have some kind of hard drive at your home, right? Because you might have changed some companies, you might have photos and all, you might have kept it somewhere, right?
Yes.
Yes. But nowadays, if you see how many people are using those hard drive, only the organizations are using. As we are not using, we are using some kind of drives, Google Drive, this drive, that drive, Oracle Drive, any drive. Why? Because if I am today using for 10 photos, I am just paying for 10 photos. Tomorrow, why should I will pay what I am not using? Look into your storage, the hard drive, what you pay 5,000 or 6,000 rupees, and you are keeping it home, right? And even you don't know after 10 years the pictures you can recover or not. But if you look into the systems what nowadays is getting designed, they are thinking on that way. If today I don't have customers, let's make scale, my scalable up to 100 customers. If tomorrow, if millions of customers are coming, I don't care. It will be automatically get scaled, right? So those kind of mechanism we need to think of when I'm designing any kind of application or any kind of system. So once again, guys, I'm more focusing on system, not any application. Whenever I say application, it's basically a software application. There might be people who are actually into different design also, right? So you can think of like what kind of system you are going to design. Let's say automotive industry or let's say semi industry. Their systems are totally different, right? Than a software. Okay. So with that, I will go to my today's last part. Like basically, I just want to reiterate like what kind of system designs are available or types of system design which is available in market at this moment. Um, you know, um, Anybody have any thought? Have you ever seen this, or you have been working on this, or anything? Guys, open to all. Okay, it seems people are not ready to, answer. They are just, guys, once again, see, this is a difference between a classroom training and a training at Udemy and, training at any Coursera or something. There is nobody there to tell you, okay, this is what, or there is nobody to answer your questions, right? They have limited question answer sessions. But here, only thing that we are virtually allocated, but you can have any questions. You can share your thoughts, guys. And some people who have been attending this course just to give interview, guys. If you are not going to open here, even you read for 100 days, months, years, you are not able to answer anything if you are not going to actively participate in any kind of discussion, because this, as I said, like in the beginning, it's a discussion rather than I give something PPTs and you take it and you say that, oh, Tapas is just another, Udemy guy. He just copy pasted everything from Udemy and just swing us. Because see, the way I have structured this entire course, some or other places I bring it. Some uh, you know some universities data, some website data, all of things you will find it. Okay. Okay, if anybody have not anything, let me go through the types of system design. So if you look into the world, there are basically three types of design available. One is monolithic, one is service-oriented architecture, which is, another one is microservices. Once again, these three are actually time-based. So down 10 years back, uh, 15, 20 years back, it was all monolithic application. And in between, 2000, after 2000, 2005, almost all every application which was in the market was service-oriented architecture. But now, if you see, all these monolithic and service-oriented architecture are moving to microservices. Why? Because all of those aspects what we gone through that, to mitigate all those aspects, they are coming to microservices. Even those bigger organizations who was very rudimentary and old, persisting in the earth from last 100 200 years, they are also moving into microservices, right? Why? There is a reason. So we will go through what is a monolithic. But guys, once again, every application have their own pros and cons to get into. Uh, Believe me or not, few months back, I was in an organization, and where Rishima was also working, um, and we were using a monolithic application. And when I say monolithic, that monolithic application is not a small monolithic application. It is just Mount Everest. It is like Mount Everest. So it's having around 40, 50 million lines of code, where things are very monolithic, and where Rishiba and her team was trying to bring it to microservices, and they were trying to write it in a microservices way, and working with that, right? So as I say, like monolithic is still used because it has having its own advantages in terms of system. But we will see where exactly it will be monolithic. Okay, so guys, tell me, let me understand. A operating system, it's monolithic or it's a microservices? Anybody want to answer?
Maybe earlier operating systems was monolithic, right? Maybe
Even
microservices are
today,
coming new.
even today,
Hmm, I'm not sure of any operating system which is microservices based now.
okay. So let's think of, if you look into a a operating system, it's a single system, right? Yes, it is on your hardware, right? It works as a single system. Inside that, whatever there, it could have been written in a monolithic way. I mean, like they might have designed, but whenever I am using a operating system, it is inside my system. It has been. If I want to upgrade it, or if I want to change my operating system, how it happens? I just need to install the entire system, right? Isn't it? The entire package I need to install on my machine. After that, when I upgrade it, it may only upgrade to one particular component of my entire system, but it need a restart, right? Every time, isn't it? Because it's a very contradictory thing. Please, I mean, guys, participate and let me know your thoughts. Whether operating. Thanks, Naidu. I mean, like, really appreciate.
Yeah. So, but when you upgrade an operating system itself, right? It's almost like you have complete downtime. It's not that.
Great. So, what it is? It's a monolithic or microservices.
Then it should be
Yeah,
monolithic, I think.
Fantastic. Sorry, I didn't get your name.
Nidhi.
Nidhi, fantastic. See, guys, this is where things comes into picture, right? Where monolithic is still needed. It's a single system, and I'm trying to once again trying to emphasize, right? It is a design. Somewhere the design is still needed in that way, right? Operating system is base of a computer, like it's a hardware, bare metal hardware, and top of that, which is going to help that run to that hardware is, you know, it's basically a software or firmwares or anything. Those will be always monolithic in nature. So when I say monolithic in nature, when you restart, when you do the upgradation, it is monolithic in nature. But the way we are writing, still you can chop them into different. Okay, can anybody tell me what all things there in? I mean, just a basic concept. You might have definitely studied about operating system. What are there actually in a operating system? Booting, semaphores, process handling, right? All these things are there. And if I take them each and every component, I can still build a microservices approach, right? But why it is monolithic? Because it comes with a single package and it need always a restart. There are hardly any component which can be run in an operating system without restarting it, because whenever I have an operating system, it basically talk to the firmware and the hardware, because there are hardware intensive codes has been written. Unless until I don't restart, they generally take it out. There are also there are patches where we don't need restarts also. So basically, if I say a operating system, it might have written in a microservices way, but it's a entirely architecture which is monolithic, more or less, right? It's run in a single system, and it's not a kind of distributed. But at the same time, if you look into VMware or all those um, applications where we put it into cluster, those are not those are not monolithic in nature, right? So let's get into stuff. I will keep on giving an example of e-commerce because it will be easy for you to understanding. So look into the monolithic architect, old days of e-commerce. So anybody have joined any organization 20 years back or 15 years back? Not after that. After 15, before 15 years, all these things has been changed. If you still remember, the applications were running on your data center. So one website we might have given to you, okay, and all you have a user ID password. You log in into this, and you will try to get something, some or other thing, right? Every application bundled as a single package has been installed. Okay, any one of you guys have been worked on application servers like WebSphere, WebLogic, Oracle application server? Anybody have worked on those things? No, or you never heard these things?
Yeah, I had some experience on Silverstream, which is similar to WebLogic.
Right. WebSphere, WebLogic, and all. Guys, those days, even now, those are running. But what used to happen? So basically, in MVC architecture, I will put my entire application, all the business logics into the application server, and I will install all my .html, .jsp files into one web server, and RDBMS all changes I will do in RDBMS. Then I will start the machine. Okay,
It's
so
basically a three-tier architecture, right?
yeah, this is a three-tier architecture. You can see over here, right? Client, e-commerce, the business logic, and RDBMS. The three-tier architecture, and it's a monolithic one basically. If I want to do any change, right, I need to create a package which will go to your basically application servers. So guys, one second. Today also application servers have been, because those are very costly applications and software that has been used. Now also we are using for them to do microservices, but it is really hard, tough. But if you guys, whoever worked, as I say, if you remember, we used to get a tar, entire everything will be there. I just put it into my application server, restart the application server, then it will run. Okay. But nowadays, you even never know how many patches are coming to your, let's say, Amazon, Netflix. You never know. Meta, you never know, right? Because the way it has been built, no, downtime, no thing. Okay, let's get into the advantages of, see, as I say, like everything have their value, everything their advantages and disadvantages. Only things are very simple. As I say, like right now also it has been used. It's very straightforward. If you have that kind of hardware, that kind of bandwidth, go for monolithic. It's not harmful, and but the worst part of that, if anything get failed, you need to entirely get into the old system. Okay, you need to take a backup, and you need to roll back to the previous system, right? So those are disadvantages, but let's go with advantages. Yes, performance. Why your operating system works very faster? Because they are in single place, single hardware, single component, isn't it? That is where the performance will be very high, right? Because they are tightly coupled with each other, right? If there is a global variable available, that global variable is within that particular circumstances, right? That's where the monolithics are very faster and get a faster response than anybody else. Disadvantages: scalable. Yes, this is one I was keep telling you, right? So if you are using monolithic application in a, you think of a computing system, where uh, 36 GB RAM is there, and dual core system you are using it. If there are more than 10 people who started using that machine, it's going to be crash. So what you need to do for the scaling of that? You need to create 10, 15 similarly, what we call as a vertical scaling. You are spending too much of money on that. You are creating each and every hardware, and which is really tough to manage, right? That's not scalable. I still remember, whenever we have storage issue, we will be keep adding storages, rather than doing some kind of optimization and all. We'll be keep adding storages, and Oracle has made a lot of money from all across the globe just providing this RDBMS. Okay, flexibility. Implementing new technology or framework with monolithic application can be cumbersome, leading a slower pace of innovation, right? So as I say, it is not flexible. Whenever you have to do, you have to do. And believe me or not, guys, I know people who are just 10, 15 years of 15, 20 years experience. They can tell you any monolithic application written on same language. But if you look into application like Amazon, Google, it is not language specific. It is just your microservices specific. It does not care if he knows Java or she knows Python. It just needs to integrate everything. It works like an event. That's all what we need. So, but monolithics are not that flexible, right? That is what I want to conclude here. Why monolithic is not so popular nowadays? Because of their own challenges. But as I said, it's simple. Their performance wise, they are really good. And if you look into the companies like Semi Domain and all, they have still monolithic because of this reason. They have not moved to microservices and all those things because they send their applications with it to the fab. So if you look into the X-ray machines and all, right, those are also used monolithic applications. And because it's a huge in nature. I mean, the work it has to do is a kind of task which can happen within that room and within that premises. That is not needed to fetch anything else, get paid and all those stuff. That is external system. But when you look into your e-commerce system, where I need to pay, quickly go, right? Okay. So then comes service-oriented architecture. And guys, this is the era where all the bigger softwares has been built. Okay, that service-oriented architecture, and which is basically 15 years back from now. You name any company, they have a service-oriented architecture. You take Oracle, you take Microsoft, you take Google, you take Amazon. Everybody is based out of service-oriented architecture. Basically, you know, they buy from somebody some services, they started running it. They buy some services and all, they started running it. So you guys might have heard about a domain called MIS, Managing Information System. Do you guys know? Okay. So basically, when I say managing information system, the captive of a organization, where all those, your information goes, your salary information goes, and your work day, your billing cycle of the organization talk to their vendors, they sell the products and all. So those the applications what they use, those are mostly as a service oriented architecture, because they integrate all those applications into their system so that they can ease of use. Because let's say they are using finance, SAP for finance, they are using from lead to order, Salesforce.com. But how they are going to manage them all together? Like, they need to bind all these services into one place, and then they start using it. So now I will show you. Okay, so look into the architecture very carefully. So when I say service oriented architecture, so basically there will be a service bus. So what we call ESB, and Oracle ESB is very famous. Oracle Service Bus is very famous to do this kind of job, which have different kind of integration mechanism, where let's say CRM is Civil CRM, or SAP CRM, or your Salesforce CRM. Order management is by once again by Salesforce or Oracle, and billing is mostly from SAP, right? So how I'm going to mingle them? How I'm going to get those things and their services and start using it? So this is the era when all these architecture get into place, and they create a boom. They create a business actually. Okay, a client is just going to use it from some website or some desktop client, all those applications, and those services might have pulled out from some or other organizations, and they have written their own services in their own application. Doesn't matter what they give you, the APIs. Even still also we use this kind of environment, but in very refined way, right? Let's say, think of, okay, how many guys you are from automotive industry? Anybody is from automotive industry? Yes? No? Okay. Uh, so, so anybody from this MIS industry, like basically where the information system, IT department of the company runs? No? All you are from the product groups? Basically, you are all for the product companies?
Yes, yes, yeah.
Yes.
Okay. So which product can you just name it? I could relate it.
Workforce management I'm working with.
Which one? Which one?
Workforce management, human capital management product.
Okay. So if you look into human capital management, so let's say you have a software, right, which is basically take care of, how many people get, how many resources come into that organization, what is their salary, what is their. So basically, if I look into that, that's a, uh, you know, workday. So basically, workday kind of stuff, right, Nidhi?
Yes, yes, Tapas, yeah.
Right. So look into workday kind of stuff, right? So they use a lot of different system. Let's say workday don't have. Yeah,
Because it is already 2020, I think people have started working because we can.
I'll take another 5 minutes because the next one is mostly the microservices. I will just take through, SOA, just a second, SOA, and I will just take the advantages, disadvantages, and I will probably leave for the day. Okay, so guys, if you look into this kind of industry, right, human capital, they are okay. They might be creating their products, but who are using them, right? They might not be straightforward. So let's say I took Nidhi's application, but my entry and exits are driven by Kronos, right? So they will give the inputs and outputs, right? They will give in time, out time. Based on that, maybe Nidhi's application is going to calculate the money, how much money this person is going to get it, right? So that's how um, basically SWA came into picture and where it is very, very useful. Uh, Once again, you guys know service reusability. As I say, like I'm just going to use somebody's service who have written. I don't care what he is. I just use their API, call that API, and use on my system. Easy maintenance because it's none of mine, right? It is very much from different people. And as I said, it's platform independent. You don't need to write any kind of platform. Only what you need to write, how my business will be understood by Nidhi's business or Naidu's business. That's all. Availability. And availability is also very, very good over here because it is not posted by me. I need to get a contract signed by the other vendor. Okay, what is your availability? If that is fine, and we agreed, that's all. And it is also scalable because nothing runs on my premises, right? I use somebody's application, somebody's thing, and I just need to tell them, hey guys, I don't need to spend much money on this, right? That's how it is scalable also. When I come to disadvantages, okay, highly overhead because everybody has to talk, there is a sign, their agreement should be signed, what they use. And okay, let's say I am doing some kind of changes, I need to validate. Okay, I did work for around 5 years on this kind of environment. Guys, our releases go for 2 days, 3 days. Why? Because we have a overhead for testing, right? The validation. If I give some parameter, somebody else should do the validation, right? So that's a huge thing and high investment. As I say, like I named it, you have to get the subscription. You need to pay for that, right? And it's very costly. And once again, complex service management. And you need people for this to service them, talk to all the customers and all. And that is the place this SOA become a failure. And believe me or not, it is nothing but a distributed monolithic application. Maybe everybody is having their monolithic application and it has been distributed across and everybody is managing that, and that is where it got failed. I mean, I won't say it got failed because everybody is running that, but the craze has been reduced when it comes to the people like millennials and Gen Z's. That kind of attitude, to develop something on that and all, it has been reduced, drastically reduced. So what came next? The latest is nothing but microservices. Okay, so I am going to leave you here, guys. What is microservices? Basically, each and every uh, you know services or every call is going to be a small application. Even the back other application is not there, related application is not there, still it will run, right? That is how it is micro. Basically, it is small. It's like a boutique of all the flowers, right? So. Uh, you does not need to be all roses, all any other flowers. It is combination of different flowers, and it does not care how you are writing it, what kind of language you are writing. You just give a API, you just get it. And even DB also, you don't need to rely on your um, you know transactional, basically your DBMS. You can use any kind of database and you can scale how you need, because there are new technologies, new ways of things has been come for this. And basically that's where the microservices is ruling the world now. I will give my next slide, maybe just 2 slides, and I will leave you there to read more about microservices and their stuffs. As I say, like it's robust, scalable, and that is what Naidu was keep telling right in the beginning. So I want to understand how I can make a system very robust, scalable. I can test it anywhere, easy to change and replace. As I say, like if I do have to change something, I just easily. I don't need to bother about others. I don't need the downtime and all, right? And one second, it is a lot of technology involved. So these are the disadvantage for this application, right? There are a lot of complexities, and yes, skill sets are very shortage. Everybody, so you need to be a full stack. You need to know everything. You need to be a master of all trades, right? That is what. And yes, confusion on getting the right size. Everybody is having their own way of saying that, okay, no, this is my size, what I need for computing, this is what I need. This is a big chaos there. Yes, team need to manage end to end of the service from UI to backend to running the production. Guys, this is where I'm going to leave you. I am not going to show you rest of the things. Rather, we will try to cover when it will come to, maybe when we'll get into the next classes or something. I will take you to the characteristics of some microservices and all those part. Okay, guys, I'll give 2 minutes for questions. If you have anything, we will, or else we will leave.
Fine. Thank you, Tapas. I will
Thanks,
drop.
Rishiba. Thanks, everyone.